So right now we're inspecting all of our guns. We're making sure that all of the lift cups are out of it. These mortars, there was no forecast for rain, but Mother Nature decided differently. So we got a little thunderstorm went over these guns yesterday when we weren't using them. So this morning we had to tip them up, drain the water out, let them dry. So we're making sure that any of the paper that's in the bottom, double checking to make sure 100% of it's removed so we don't have any wet paper remaining in any of the mortars. One of the other quick techniques I wanted to show is that when we set our racks up, we try to make sure that our end boards don't overlap one of the racks. That makes each one of these positions, even though it's one position, it is independent. So if we have to tip the racks up like this, it's just one rack at a time or one set of racks at a time. If this was all screwed together, it would be very, very heavy, and you would need a lot more than one or two people to pick up a whole set of racks. So over here, they're independent. Over here, they're overlapped, but they're not screwed together. And over there, you can see our 3-inch. You know, part of it was screwed together over here, but part of it was not, and it was split. So again, it's a smaller assembly so that one or two people are able to tip it up or tip it down. So again, there would be no way to do that without a lot more people if these were all screwed together. Each rack of 5s weighs probably in the neighborhood of about 70 pounds. So we have about 10 racks here, so there's about 700 pounds worth of racks. You know, 2 people can do that if they're all divided up into smaller groups, but again, for us to bring 700 pounds down and try to control it, it would just come slamming down, and people would try to hurt themselves trying to lift it up if they were trying to tip it up. So again, dividing it up into smaller pieces, but having it close enough together, you can get all of your E-matches, you know, connected to your rail, makes it a lot easier to get set up. And if you need to tip them up to drain water out of them, it makes that whole process much easier. So this is an example of our 5-inch racks. A couple of things you'll notice is, first of all, we use plywood end boards. Plywood end boards gives a lot of stability. We end up using a screw. These are a square head and a Phillips. Very common and easy to get bits. On a 5-inch rack, we're going to put 3 screws in each rack, and this provides a lot of stability. So when you push on these racks, they're, you know, together as a very solid unit. You'll also notice we purposefully don't connect this unit to that unit. And what we'll do is we'll tip them on their side, so we don't necessarily have to cover them in plastic to be able to protect them, because we're going to have a show 2 days later, and if we got a rainstorm, we don't want to have a bunch of wet guns. All of our mortars have holes in them at the top. We always tie each E-match wire in 2 spots. We tie it right at the muzzle. We also tie it to a secondary tie, a screw, and you'll notice there's space between all the mortars. This does a couple of different things for you, one of which is if a shell were to fail in the mortar, it provides a lot of room for the shell to vent. So if it breached a mortar, it's got a large airspace to be able to vent. Doesn't mean it won't necessarily damage the rack next to it, but the damage is going to be significantly less, and it may not even damage this rack. When they're tight together, you haven't given them any room at all to be able to vent, and what they have to do is there's all the gases that have been released by the shell that failed in the tubes got to go somewhere, and so it has to go through the rack that's next to it. So we use our calibrated fist, and we use a fist width between each of the racks. That also makes it a lot easier when you're tying off to the top to be able to have room. When the mortars have space between them, it's a lot easier to be able to tie each of these knots at the top. When they're really, really close together, it's a lot harder to be able to get in there, you know, if you have another mortar that's only, you know, an inch away. If you look down the rows here, you'll notice that all of the wires they're not super snug, but there's no slack. And the reason we don't want any slack is because if there's slack, a wire could get up and over another mortar. a lot of times when we find shells left over at the end of the night, we investigate them, and if the wire was slack, a lot of times the wire will be broken, because if this tube shoots first and this wire was over the top of the tube, you know, it's going to break the wire. So again, you know, just making sure that they're all nice and neat. And then all these little tails here go over the wire here. So if this wire was to start to come up, this kind of traps it underneath. And just having these little tails and taking these tails and putting them out like this kind of acts as a trap from that wire, preventing that wire from being able to get up and over that mortar, even if there was some slack in that wire. The space between the mortars also gives you a really nice place to take the wires and be able to put them in between the mortars, so you can have nice and neat wiring. If we had rain, what we would do is we'd cover this in plastic, and then we would end up putting strips, like furring strips, like 1x2s, and we'd roll the plastic in it and we would screw it right here. And by having all these wires nice and neat and kind of tucked up, you don't have any wires hanging down in the way of where you are trying to attach plastic. Everything's out of the way, it's nice and neat, everything's protected. So that's just a few of the techniques of some of the things that we do to help us get 100% success and 100% firing in our shows, and also, you know, the extra space between the racks really adding a safety enhancement, as long as you've got the room to be able to do it, that, you know, really has limited damage to equipment, and also help to maintain rack stability if you do have a failure in a tube.